Greetings of the day. Myself, Dr. Prakash, Assistant Professor in Mechanical Engineering Department, Madnapalli Institute of Technology and Sciences. Today, I am going to discuss about the PPT regarding the mechanism of the machines, which is related to the uh, kinematics and dynamics and theory of the machines. So let us start with the definition of the machines, as this topic name is the machines and the mechanism. So what is the machines and what is the mechanism? So a machine is a device which receives energy in some available form and transform it into some useful work. A machine consists of a number of parts or bodies or links. What is the example of these machines? So whatever we have seen usually surrounding to us, like fans, computer, lathe machines, milling machines, air conditioning units, all are come under the category of the machines. So these machines are operated on the basis of different type of the components, and these components are working on the basis of different type of the mechanism. So another definitions of the machine is when a machine is required to transmit power or to do some particular type of work, it then becomes a machine. Then we have required to know about what is the mechanism. So if a number of bodies or links are assembled in such a way that the motion of one cause constrained and predictable motions to the other links, it is known as the mechanism. In other words, we can going to define the mechanism like when one of the links of the kinematic chain is fixed, the chain is known as mechanism. This is the technical definitions as per the syllabus, theory of the machine and kinematics of the machines, kinematic and dynamics of the machines. It may be used for transmitting or transforming motions, that is engine indicator, typewriters, etc. Now in this topic, inversion of mechanism is very important. So what is the inversion of the mechanism? The method of obtaining different mechanism by fixing different links in a kinematic chain is termed as inversion of the mechanism. Various mechanisms can be obtained by fixing different links by turn. So in a kinematic chain, we can find different type of the mechanism. So now the question is that what is the kinematic chain? So when the kinematic pair are coupled in such a way that the last link is joined to the first link to transmit definite motions. What is the definite motions? That means completely or successfully constrained motions. It is called a kinematic chain. So if we going to discuss about the kinematic chains, so what is the type of kinematic chains? So mainly we are going to study about the three main types. First is the 4-bar chain or quadratic cyclic chain. Second is the single slider crank chain. Third is the double slider crank chain. Also, we are going to discuss about the inversion of these kinematic chains. So first one is the 4-bar or quadratic cyclic chain. So it is the simplest and the basic kinematic chain in a in the category. It consists of 4 links. Each of them forms a turning pair. As shown in the figure, turning pair is associated with A, B, C and D. The 4 links may be different lengths. It can be associated, and these 4 links is the AB, which is termed as link 1, which is acting as a frame, link BC, which is link 2, which is acting as a lever, rocker and follower, link DC, which is link 3, which is acting as a connecting rod or coupler, and link AD, which is the crank. So in this 4-bar chain, what happens if the crank is rotating, then link BC, which is the follower, it is oscillating. Okay, so there is a one complete rotations and there is a one oscillations motions with the associated with the BC. In this category, Grasshopp's law is very much important for the subject point of view. So what is the Grasshopp's law? For a 4-bar mechanism, the sum of the shortest and the longest link length should not be greater than the sum of remaining two link lengths if there is to be continuous relative motion between the two links. Now, we are going to discuss about the inversion of the 4-bar chain. Then after we are going to discuss about the single slider crank chain and inversion of single slider crank chains. And then after we are going to discuss about the inversion of double slider crank chain. So if we're talking about the inversions, so how many inversions we are able to get from the 4-bar chain? So first is the beam engine mechanism, which is also called as the crank and lever mechanism. Second is the coupling rod of locomotive, which is also termed as the double crank mechanism. And third one is the Watt's indicator mechanism, which is termed as double lever mechanism. We are going to discuss about the two mechanisms in this category, like beam engine mechanism and Watt indicator mechanism. So the figure shows the beam engine mechanism. So in this mechanism, when the crank rotates about the fixed center A, the lever oscillates about a fixed center D, as shown in the figure. The end E of the lever CDE is connected to a piston rod which reciprocates due to the rotation of the crank, which is indicated in the figure. The purpose of this mechanism is to convert rotary motion into reciprocating motions. So in this, what we have seen, the 4 links is associated with the 4 turning pairs. This type of engine are used to pump water out of the mines. Now we are going to discuss about the another inversions, what's indicator mechanism, and it is also termed as the double lever mechanism. So the figure indicated is shows this inversions. So what is the Watt indicator mechanism? A Watt's indicator mechanism, also known as Watt's a straight line mechanism, which consists of 4 links. Why it is called as the straight line mechanism? Because its actions, final actions, gives the a straight line motions. The 4 links is associated with this type of mechanism is the fixed link at A, the link AC, link CE, and link BFD. Here we can see that we termed as a link BFD as a once, because this acting as a single link. It may be noted that BF and FD form one link because these two parts have no relative motions between them. The links CE and BFD act as lever. The displacement of the link BFD is directly proportional to the pressure of the gas or a steam, which act on the indicator plunger as indicated in the figure. On any small displacement of the mechanism, the tracing point E at the end of the link CE traces out approximately a straight line motion. The initial position of the mechanism is shown by full lines, whereas the dotted lines shows the position of the mechanism when the gas or steam pressure act on the indicator plunger. So where is this type of the mechanism we are going to utilize? So this mechanism can be used for measuring the gas pressure in engine cylinders. Now we are going to discuss about the single slider crank chain and inversion of single slider crank chain. So whatever the figure indicated in the PPT, it is showing the single slider crank chain. This mechanism consists of one sliding pair and 3 turning pair, as name indicates. Because name indicates single slider, so one single slider and remaining 3 is the turning pair associated with these machines. It is found in reciprocating steam engine mechanism. This type of mechanism converts rotary motion into reciprocating motion and vice versa. So in this single slider crank chains, how the links are associated. So link 1 and 2 made the turning pair, link 2 and 3 made the turning pair, link 3 and 4 also made the turning pair, while link 4 and 1 made the sliding pair. Now, what should be the inversion of the single slider crank chain? There are different type of mechanism uh, we are getting by the single slider crank chain by fixing the links in turn. So, pendulum pump or bull engine we are getting by fixing the sliding pairs, and by fixing the connecting rod we are getting two type of the mechanism like oscillating cylinder engine, crank and slotted lever quick return mechanism. By fixing the crank, we are getting rotary internal combustion engine as well as Whitworth quick return motion mechanism. So in this, we are going to discuss about the oscillating cylinder engine. So what is this? The oscillating cylinder engine mechanism is used to convert rotary motion into reciprocatory motions, which is clearly indicated in the figure. In this mechanism, the link 3 forming the turning pair is fixed. Let the link 3 corresponds to the connecting rod of a reciprocating steam engine mechanism. When the crank link 2 rotates, the piston attached to the piston rod link 1 reciprocates and the cylinder link 4 oscillates about the pin pivoted to the fixed link at A as shown in the figure. So in this we are getting a single sliding motion and 3 turning motions. Now we are going to understand about the crank and slotted lever quick return motion mechanism, in which also mainly four links are associated. So in this diagram we are clearly able to see link 1 is the slider, link 2 is the crank, link 3 which is fixed is a connecting rod, and link 4 is the slotted bar. So what type of the motions and what type of the output we can getting from this single slider crank and slotted lever quick return motion mechanism? So in this slider is moving inside the slotting bar, and this slotted bar is oscillating between the points B1 P1 to A B1 P1 to A B2 P2, and due to the full rotation of the crank. So during the full rotations, one angle beta is making and one angle alpha is making as shown in the figure, and through the slotted bar a ram which associated with the tool is connecting, and this tool is reciprocate with the use of the slotted bar, and such type of the mechanism is widely utilized in the shaper machines. So in this mechanism, the angle beta made by the forward or cutting stroke is greater than the angle alpha described by the return stroke. Since the crank rotates with uniform angular speed, therefore the return stroke is completed within shorter time. Thus it is called quick return motion mechanism. And how can we get the quick return ratio? So it will be the it is the ratio of time of cutting a stroke to the time of return a stroke. By as shown in the figure, cutting a stroke made the angle beta and return a stroke made the angle alpha. So this will be ratio of beta to alpha. We are moving forward to double slider crank chain. As the name indicates, this type of the mechanism is associated with two turning pair and two sliding pair. So what is the inversion of double slider crank chain? How many types of inversion we are getting? So in this we are going to study about the elliptical trammel, which is the one type of the inversion of the double slider crank chain, and a Scotch yoke mechanism and Oldham's coupling. So what is the elliptical trammel? So this type of the mechanism is utilized for drawing the ellipses. This inversion is obtained by fixing the slotted plate link 4 as shown in figure. The fixed plate or link 4 has two straight grooves cut in it, as well as the link 1 and link 3 are known as the sliders and form sliding pairs with link 4. The link AB, which is termed as link 2, is a bar which forms turning pair with link 1 and 3 as shown in the figure. When the link 1 and 3 slides along their reciprocative grooves, any point on the link 2 such as P traces out an ellipse on the surface of link 4 as shown in the diagram. So like that, ellipse can be formed utilizing the elliptical trammel. Now we are going to discuss about the another inversion of double slider crank chain, which is Oldham's coupling. So figure 1 is shows the there is a two shafts two misaligned shaft is connected with this Oldham's coupling. So, an Oldham's coupling is used for connecting two parallel shafts whose axes are at a small distance apart. What is that meaning? That means two misaligned shafts is usually joined by this Oldham's coupling. The shafts are coupled in such a way that if one shaft rotates, the other shaft also rotates at the same speed. This inversion is obtained by fixing the link 2. Also, the link 1 and link 3 form turning pair with link 2. The flanges have diametral slots cut in their inner faces as clearly it is indicated in the figure A. The intermediate piece, link 4, which is a circular disc having two tongues T1 and T2 on each face at right angle to each other, which is indicated by diagram B. The tongues on the link 4 closely fit into the slots in the two flanges, link 1 and link 3. The link 4 can slide or reciprocate in the slot of the flanges. So, in this actions, what happens? The shaft is two shafts which is connected is rotating with the same speed. Now, these are the references. Thank you.